Hello guys, welcome back to section 4 or video number 4 in our introduction to object-oriented programming with Python series. So we're going to be going ahead and learning the four main pillars of object-oriented programming. So I've covered all the basic stuff of object-oriented programming. We've looked at what are classes, what are instances, what are objects, what are methods, the different types of methods we have in Python, the special methods and all of that. So we are good to go now to more to cover the four main pillars of object-oriented programming in Python. So if you're going for a job interview, or like if you're having a college, if you're in college, you're doing exams, these are the questions, the four main things I'm going to ask you about object-oriented programming. So let's take a look at them. So the first one is inheritance. Okay, the first one is inheritance, the other one is polymorphism, another one is encapsulation, and another one, the last one is abstraction. So they don't actually come in any specific order, but I'm just going to go ahead and explain to you things from the easiest point or to the more difficult as we go along. So the easiest which I can explain to you is easy to understand is going to be inheritance. So we'll start talking about inheritance. We'll move on to encapsulation, also look at polymorphism and abstraction later on. So in this section, we'll actually be covering inheritance in Python. So what basically inheritance is in Python. So inheritance, let's say that you're a human, right? And you inherited some things from your parents. Like maybe your eye color is let's say brown, and your dad's eye color is also brown. So probably you inherited the eye color of you inherited your eye color from your dad, right? And let's say that your mom has maybe green eyes and you also have green eyes, then you probably inherited that from your mom. Your dad, maybe your dad has a car, and if your dad passes away, unfortunately, all that car, like houses and other stuff, other resources, come to you, right? That's supposed to be, right? So in case like your dad doesn't hate you or anything, then all those things come to you, right? So all the houses, the cars, and everything comes to you, and that's what we use the word inheritance to mean in normal English, right? This is the same thing in programming. Basically, we use inheritance for three main things: to extend the behavior of one class, to override and overload. Okay, so we will not be Python. We actually don't do overloading, like method overloading. We can do it, but not like in a generic way like other programming languages like Java or C++. But it doesn't really matter much in Python because the approach that we have is significantly significantly enough. Okay, and you can also do method overloading, but with a bit tweaks and tricks. Okay, but we cover mostly how we can use an inheritance to extend the behavior of a class, also to extend a class to another class, and also use it to override stuff. Okay, so that's basically it. Like for example, if you inherit a house from your dad, you can build other houses of your own, right? So you have your dad's house and you also have your own houses. And if your child inherits from you, it's not only inheriting things from your dad, but also you are included, right? He or she inherits your dad's house plus your house, right? So that's you can use to extend stuff. So don't worry about all this. We'll look at it just in a second. So yeah, let's jump into the code and let's see how inheritance can work. So this is the class I've been using so far, the file that I've been using so far. So I'm going to go ahead and create another file. So I'm going to call this one part2. So this is going to be part2 underscore part2.py. Okay. So once I have that, I'm going to go ahead and close my side panel. So let's say that we have an animal class. Like I'm going to use the animal example because it's most like we are all from the animal kingdom, like humans. So I think it's much more easier to understand. If you're not a fan of biology, don't worry. I won't go too much into biology. I'll just use normal human terms to explain things. So let's take an example of animal. Like all humans are animals, right? All of us are animals in the background. All dogs are animals. All horses are animals, right? And we all inherit some common traits from the animal class. Like we can all breathe. We are all alive. We can all move and do stuff like that. These are all traits from the gen that all animals have, right? So you can think of an abstract animal class that we all inherit from, and we inherit all these common traits from that abstract animal class. So all animals have a name, they have and what they eat, what the animals can move, and all of that, right? Animals can die. We all inherit all these traits from the sub animal class, that is the super animal class. So let's try to mimic this with code. So I'm going to create a class right here. I'm going to call this class animal. Okay, so this class right here. And once I have the class, I'm just going to have an constructor that's going to go ahead and simply store a name of the animal, right? So I'm going to call this, and I'm going to say self.name. I'm going to pass equals to name. So I'm going to expect the user to pass in the name, okay, when creating the object. So it says name, and name is going to be of type str. Good. So once we have that, we have the constructor created, right? So we also say that let's actually add some regular methods in here. Animals can eat, right? All animals can eat. So self, and I'm going to go ahead and simply print, let's say eating, okay, just like that, eating, okay. And then I'm going to also animals can also what can animals do? That's common to all animals. Animals can move, right? So we have self, and you can go ahead and say print, let's say moving, moving, just like that. Good. Let's go ahead and actually add another animal trait. Let's say animals can breathe, right? So there is a def, and you say breathe, breathe, just like that, and taking self, and all animals can breathe, and you're just going to print, you say breathing, breathing, okay, breathing, just like that. So that's it. And these functions right here, okay, sorry, these methods rather, we can go ahead and actually specify the return type of them, which is going to be none. So because you're trying to use modern Python syntax, so I would like to include type int in here. So this methods return none, okay, and also here we have none being returned, so none. Okay, so this is just modern Python syntax. Okay, if you don't want to include it, it's fine, but I advise you to do so because a lot of libraries, new libraries in Python are adapting type hints. So it's just good that you use them and to get comfortable with using them. So once you have created this animal class, let's go ahead and create an object of this animal class. And you learned all this from the basic last videos, right? So you can check those out if you haven't checking them out yet. So we're going to create an animal. This is gonna be an animal, and it's gonna be of type. Okay, let's say animal, and let's say animal, just like this, and then call it animal. Right, this is not specific animal, so just going to go ahead and simply call it animal. So I'm going to go ahead and save this. Okay, if you want to use type int, you can go ahead and specify which type is it, and this is of type animal, just like that. So good. So we have created an animal, and you can go ahead and call different stuff for this animal. You can say animal.eat, right? Animal.eat. You can call animal dot breathe, and we learned all this when learning the basics of object-oriented programming, okay, in the last video. So just gonna clear the terminal and run. This is gonna be part 2, right? So part 2, run it. Now you can see breathing and eating. Yeah, eating and breathing, right? So good. Now I've created this animal class, but there is no generic animals, right? There is no generic animals, right? We don't have generic animals. There's all animals belong to a specific class or subclass, right? We don't have anything that's called animal. Like we have humans, and humans are subclass of the animal class. We have dogs, also sub animals. We also have goats. All of those are subcat animals, subclass animals, right? Of the animal, of the major animal class. They're all under the animal kingdom, but they are different parts of the animal kingdom. Okay. So so once we have that done, so how do we represent subclasses with code? Let's say that we want to create a human subclass, but this human subclass has is going to be part of the animal class, right? Because humans are basically under the animal kingdom, so they're going to inherit some common traits from the animal class, right? So humans have some common behaviors to other animals. Like humans can all eat, right? Humans we eat, humans we move, humans we breathe, and all this is coming from the major animal class that you are part of as humans. So humans we inherit some of these traits from the animal kingdom, right? The animal class in this case. So how do we make this with code? So let's go ahead and actually create that. So I'm just going to go ahead and create an object here. I'm going to create a class, and this is going to be a class called human class. So just as I created this class, I'm going to simply do pass create because this is an empty class, right? So I showed you how to create an empty class. But this human class, humans are under the animal class, right? We're going to inherit from the animal class. And how do we do inheritance? We simply say animal, and that's the whole point of inheritance. So just by doing this, let's go ahead and create a human object right here. So you can say John, and John is going to be of the human class, just like that. And John is going to go ahead and need a name, right? When passing, let's say John. Okay, let me just go ahead, let me just remove the name first. I don't keep any name, and let me just go ahead and show you what you're going to try to do. Let's say this is going to be of type human. Just type some type insert human. So once we have that, I'm going to go ahead and run the code, and let's see what we get. We get an error, right? It says that animal init, the constructor of the animal class, which is the parent class, is using one required argument called animal. So let's say under the animal class, all animals must have a name, and that's what this constructor is expecting. So whenever you're trying to create a human, it's actually calling first the parent class, and the parent class is expecting us to pass in the name. So I'm going to go ahead and pass in the name here. I'm going to say this name is John, right? So if I go and run the code again, now that error is gone. So that you have been able to create a class. So just by inherit this is how you inherit in Python, parentheses, and you pass the name of the class that you inherit from. So we are trying to inherit from the animal class. So before you're creating an object of the subclass, right, we have to first go ahead and call the parent class. So the parent class constructor is expecting us to pass in the name of that object, and that's why we are passing in the name of that object. To understand this more, we have a parent class that is passing on stuff down to the subclass. And whenever I try to create an object of the subclass, the parent class constructor must be called first before the child class constructor, and that's why we are expected to pass in name in here, because the parent class, which is animal, is constructor requires you to pass in a name. right? So basically, we have to create an animal first before creating human. That's what you can think of it. Like humans are animals, right? The animals can't like humans can't exist without first being animals. They must first be animals, and then they are categorized on which type of animals they are. So that's basically how you can think of it. So good. Now that's how you can do inheritance in Python. So let's also go ahead and let's create another subclass. And this subclass, we're just going to call it dog, and it's going to inherit from the animal. So you can say class and dog, and it's going to inherit from the animal class. Okay. So I'm not really good in. I'm not going to go ahead and too much into biology. I don't know. Maybe animal. I don't know dog. I don't know which class dog belongs to in the animal kingdom. But this is just for you to understand, right? You're not focusing on taxonomies and stuff like that. Okay, so now once we have that, let's go and actually create an object of dog. So let's say that this job is called Skippy. Skippy, I don't know. Yeah, Skippy like that. And it's going to be of dog. And you're going to go ahead and give it, you're going to say it's going to be dog. You're going to pass in a name, right? So it's going to be called Skippy. Skippy. And if I run the code again, now everything works as we expect it to. So good. So once you have created these two, we have two subclasses, the first subclass and the second subclass, and all an object of the subclasses, right? So good. So once we created this thing, right? How can we? What can these objects really do? That because the animal class, all animals should be able to eat, move, and breathe. So by creating this object right here, the John, the animal, sorry, the human object, does it inherit all these traits of the animal kingdom? Let's try it out and see. So I'm going to simply say John dot, and I can say breathe. So you can see John breathe works, and it's printing out breathing. So meaning that you have inherited all these traits from the animal class, right? So once you inherit from a class, you inherit all the methods and the data of that class as well. So now you have inherited everything of that class, basically. So even dogs can also breathe, right? So I can say Skippy dot let's say Skippy can eat, right? And which you have inherited from the parent animal class, and can see eating. So that's basically how it works. Once you inherit from a given class, you inherit all the methods and attributes of that class as well. So good. How can you know which attributes and methods that you have inherited from that class? So let's go ahead and simply do this. Let's say print. You can say help, and I can pass in help, and I can pass in the John object. So this is going to tell us all the different attributes and data that you have inherited from our parent class. In this case, our parent class is the animal class, because everything from the animal class will be passed down to the human class, which is inheriting from the animal class. So now let's see what you have inherited from the animal class. Now we should be able to inherit everything. So let's go ahead and actually clear the terminal, run the code again. Now you can see we have this right here. So this is called the method resolution order. So if you want to see what a class has inherited from its parent class, this thing is being controlled by something called method resolution order in Python, and this is right here. So the human class, you can see the human class has inherited from the animal class, and the animal class has inherited from the built-in dot object. So in Python, you have this thing called built-in dot objects. Basically, I told you everything in Python basically is kind of object. So basically, everything in Python is basically an object. Basically, so every class inherits from the built-in dot object class. So even the animal class, even without specifying it in the background, Python is passing down some things to it from the is inheriting some things from the built-in object class. So you can see the human class, which has inherited from its parent class, animal class, which has also inherited from the built-in. So this is something that happens in the background in Python. So let's see the method inherited from the animal class. So you can see methods inherited from animal class, which is basically the parent class of our human class. So you can see we have inherited the constructor, which is this right here, and that's why the constructor is being called. Okay, so we have inherited the constructor of the parent class, whether we want it or not. The constructor is inherited. That's why we have to pass in a name first. Okay, and we also inherited the breathe method, that basically, and you also inherited the eat method, and also inherited the move method from the animal class. So you can see the importance of type hints. We're getting this additional information, so that's good to use type hints. So these are the different methods that you have inherited from it. So things that you can see, the data descriptions inherited from the animal class. You have inherited the description, which is basically give us information of the name scope, and also the weak ref, okay, with list of weak references to the object if defined. Okay, so that's basically it. What you have inherited from the parent class, and that's how you can check that using the help function in Python. So good. Now we know what you have inherited, and we have check out everything that you have inherited from the subclass. So subclasses might have some attributes and methods that the parent class doesn't have. So for example, you as an individual have inherited some things from your parent, but you have something that are also unique to you, right? So let's say that your dad has a blue eye and you also have a blue eye, but maybe your skin color is a bit darker than that of your parents, right? So some things are gonna be unique to you, right? So how do we implement that in code, right? So we have inherited everything from the animal class. How can we make sure that we have our own set that is unique to us? Because if you just inherit, then there's no point of creating this object in the first place if it's just a copy of this one. So that's the point of extending the behavior of using inheritance. That's what the main use of inheritance is, to extend another class. So we're going to extend this class to add some attributes. So humans, let's say that humans can have skin color. Humans, we can have even hair color. We can have an age and all of that. So we can pass in all of that in here. So let's say def which is underscore init this, and then we're going to pass in the name. So okay, let me just undo this again and then just type this out and explain to you. So underscore, and they say underscore, passing this, you're going to take in the self keyword. So great, so now we have the self keyword. You're going to go ahead and simply have pass here for now. Good. So I've inherited, you're going to override this method, right? So we have the constructor method that you're overriding. So you're going to be using this constructor method, because if you create an object, first of all, you're going to if you're trying to create an object, it's going to look first within this class, the human class. If there is no constructor, it's going to use the constructor of the parent class. Even if there's a constructor, basically we will use this constructor no matter the situation. And I told you before, you can create a human is first an animal. So you have to first call the parent class. So to call the parent class, you're going to use the super keyword. So you're going to use super, and you're going to say super, and then you're going to say call the super, is the business super keyword, and then say dot underscore init right here. Init right here. And what you need to pass in, you need to pass in a name. So you need to pass in name. So it's a name equals to, and then name. So I'm going to expect the person to pass in name of that human. So you say name. Name is going to be of type str. Good. So good. So we're calling the super, which is a parent class, and you're passing the parent class is the animal class, and the constructor of it expects us to pass in the name, which you're going to be passing in here. So this is going to go ahead and create for us an animal, because there's an animal in all humans, right? You can think of it like that. There's an animal in all of us. Okay. So now once we have that, a human also has a skin color, so we can give it a skin color. So I can say skin underscore color, and a skin color is just going to be of type str. You're also going to have hair underscore color, and hair color is going to be str as well. You're also going to have age, and age is going to be of type int, right? So good. So I'm going to go down. I'm going to say self dot skin color underscore color. So skin color is going to be skin color, right? So skin color, and then self dot hair color, hair underscore color is going to be equals to hair color. So hair color, and self dot age is going to be the age that is passed in. So good. So now a human now is a bit different from the animal, but at the end of the day, you have to first create an animal before creating a human, because again, there is an animal in all humans, right? So that's basically it, how a constructor we can use a constructor. Okay, so whenever you have an top level constructor that requires some parameters, you have to first call the super keyword. If the animal class didn't have a constructor, like we didn't define the constructor, there's a constructor always, like, whether you define it or not. But if we didn't define it taking in name, then we wouldn't be required to call in the super keyword. But since we need to pass in something, then we need to call it, right? So good. So what we create an animal before creating a human, because there is an animal in all of us. Okay. So once we have that done, we can also have our own method. Humans can talk, right? So humans can talk. Not all animals can talk, but humans can talk. So we have a self that's going to go ahead and simply print. It's going to be this is going to be a regular method, let's say talking, right? So this is something that humans can do that's unique to humans, right? So this is going to return to us none. So none. And yeah, that's basically it. We can also have other things that are unique to humans. So let's say the humans can dance, and not all animals can dance. So that's this as assumption I'm using. So none. And we can also have print. Let's say dancing, just like that, and dot dot dot. And I'm also going to have another function def, and it's going to be move, and it's taking this the self keyword, and it's going to go ahead and say none, returns none, and it's going to go ahead and print this is going to be moving, right? So moving, and then dot dot dot. So great, now we have all that being defined. So once we have that done now being defined, whenever I create a human object, I need to go ahead and call the human construct, which is being called in here. So you pass in the name. You also need to pass in the skin color. So I'm going to say I'm black, right? So I'm going to say black or brown. not white. Okay, so I'm going to also pass in my hair color. My hair color is also, let's say, brown. I don't know. Let's just create an uh a super, like, I don't know. Let's just say name, and also let's pass in the name of the person. Let's say I'm 26, right? So let's say I'm 26. Okay, now this needs to be an integer, right? Not a string. So an int is an integer. So once we have that done, good, we are good to go. So if I go ahead and create a human, that's big. I can access the human.name.human.skin color and do all of that. So I can just go say print John, right? Print John dot name. Okay, it's John dot skin color. Yeah, skin color. I can print John dot hair color and all of that. So if I run the code again, now we should get the skin color, which is brown, and then the hair color, the skin color which is black, and then the hair color which is brown, right? So you can see those values right here. So that's basically how we can inherit it from the parent class. And now we have overriding, we have overridden the constructor. When we have created our own constructor, basically not overridden the constructor. We have our own constructor, but you have to call the parent constructor within our own constructor because there's an animal in all of us, right? So, and we have written our own methods right here. Okay, good. So let's talk about overriding because that's another use of methods, right? So you can see we have moving, right? And moving is a class that's also within the parent class. So if you look within the parent class, we also have moving right here. So what's going to do is I'm going to go ahead and change something here. So I'm going to say human is moving. So that's basically that. So the one that we the moving method we have in the human class is say human is moving, and the moving that we have within the parent class is just saying moving, right? So now this is unique to the human class, right? So let me just go ahead and let me just come in here. Let me just comment out this for now, comment it out, and just delete it. In fact, also here I'm just going to delete it, and in here I'm going to go ahead and simply say moving. So if I say moving, which moving is it going to use? Is it going to use the moving that we define here, or is it going to use the moving that it has inherited from the parent class? So let's go ahead and run the code and let's see. So we get human is moving, right? So good. Let me just also comment this part out. So if I run the code again, we get human is moving. So basically it looks within its own namespace to find, to say John.moving, like John is an object of the human class. So it tries to look within its own namespace, right? Check if this function definition exists. If it exists, it's going to use it. If it doesn't exist, then it's going to go ahead to the parent class, and look for it within the parent class. So whenever you call a method, it first look within the subclass namespace. If it exists, it will use it within. It will use the function definition of that parent class. If it doesn't exist, that's when you need to go ahead and look for the parent class. So for example, if I ask you, do you have a car? You might tell me yes. Or okay, let me ask you, okay, where do you have a house? Like, where is your house? If I remember, I ask you, let's say that you right now you don't have a house, right? You're just a student or something. So if I ask you, where is your house? You actually give me a location of where the house is or where you stay. But that house is actually not yours. That house is actually for your parents, right? But if 10 years down the line I ask you, where do you stay? And you happen to have a house, right? You tell me where your house is and not where your parents' house is. So that's basically it. So you look within yourself. If you have a house, you refer to your own house. If you don't have a house, that's when you go ahead and refer to your parents' house. And that's the same thing that works in here. Whenever you're saying move on a human objects check within its own namespace if it has the function move defined. If it doesn't, that's when it goes to ahead and use the one of the parent class. So in this case, we have it, so we're going to go ahead and use one of the parent class. So let me just go ahead and comment out this part of the code. And now I'm still using john.moving. So it's going to go ahead in the human class. It's going to find, do I have moving? And that's no, right? Move, right? Move method. It doesn't have a move method. So it goes to the parent class and use the one of the parent class. So if I run the code again, we see we're using the one of our parent class. But if I go up here and uncomment this and I run the code again, here now we're using the one of of the human class. So that's basically how overriding works. Overriding, you override you inherit everything, but you can override some of the things that you inherit. And you can check the namespace by using, let me just print out the namespace and say print. I'm going to press say John, then I say dot underscore dict, just like this. And if I run the code again, you can see this is a namespace of John. So you can see we should have the namespace of John right here. And you can also check the things that you have inherited from this namespace. So if I go ahead and do let me just say help. Okay, I already have it here, so I'm just going to go ahead and delete this line of code right here and run this code again. So go to the terminal, run the code. Now you can see we have things that you have inherited. Okay, you have inherited move, but you have overridden the move that you have. Okay, so that's basically it. So that's basically how you can think of inheritance as working, and how inheritance can be used to override the behavior of something that we inherited. So good. That's basically how we can work with inheritance. So let's look at the different types of inheritance in Python. So we have a couple of types of inheritance. Actually, we have a lot. There are single inheritance, like what you have done so far is called a single inheritance, because you're just inheriting from one parent class. So it's called a single inheritance. We also have multiple inheritance, whereby multiple inheritance, we do not only inherit from one class, but from multiple classes. Okay, let's just say I have another class, right? Let me say class. I'm going to call this class super animal, just like that. And this class is going to inherit from no class. So for now, there's gonna pass. So this animal class is going to inherit from also super class. So super animal class. So we're inheriting from animal class as well as super animal class. So if I go here and try to print a help, if I go ahead and run the code again, now you can see that we are the human class. We are inheriting from animal class, and you're also inheriting from the super animal class, and then you're inheriting from the built-in class. So basically, we are inheriting from multiple classes, and that is called multiple inheritance. Okay, so we also have something called multi-level inheritance. And how does multi-level inheritance work? So multi-level inheritance, basically we have this class right here, and this class basically inherits from the animal class. And in here, instead of inheriting from the animal class, we're just going to inherit from the super animal class, which inherits from the uh, uh, animal class. So that's multi-level inheritance. And to explain this to you more, I even have this is single level inheritance, this is multi-level inheritance. I demonstrated this to you. This is multi-level inheritance. So we have child object that is inheriting from parent class A, parent class B, and parent class B is also inheriting from parent class A, and that's what we have in our code here. We are inheriting from the super animal, which is also inheriting from the animal class. Okay, so that's a multi-level inheritance. We also have hierarchical inheritance. This is basically how our hierarchical inheritance work. We have parent class, that's two classes are inheriting from parent class basically. So that's how hierarchical inheritance work. And then you have hybrid inheritance, which is a combination of the different types of inheritance that you have looked at so far. So it just combines them in different ways. Okay, so basically we have the parent class, and also have another class called parent class. So this parent class is inheriting from this parent class, and this parent class is also having two subclasses underneath it. So okay, if I go back in here, this looks like multiple in hierarchical inheritance, right? This the bottom section here looks like more hierarchical inheritance, but at the top here looks like single inheritance. So that's basically how hybrid inheritance work. We just have multiple different types of inheritance within one. So that's basically it for different types of inheritance in Python. So in the next section, we'll be looking at encapsulation. So you guys, if you enjoyed this tutorial so far, make sure to like the video. One way you can easily support me is by liking the video. You can drop a comment in the comment section below of any feedback, anything that I need to improve on. And also, if you want to support me, you can buy me coffee. The link is going to be in the description of the video. So thanks for watching, and see you in the next one. Keep safe.